So we have the word down here. Today we're going to be looking at a very interesting new model called SenseNova U1. Now, aside from being Apache 2.0 open source, which is always good to see, this is a unified multimodal model, which, as we'll get into later, means that essentially it does not translate between text and then to images as a native multimodal model may do for image generation, where it is text to image. This is a different architecture, and that is partially what makes it interesting. Another thing that has me very excited to play with this is the fact that it seems to excel at infographics. Now, oftentimes when we do the image model tests on this channel, they do kind of delve into chaos later on in the video, but I do find that there's probably a good balance between funny and also educational infographics, so I'm pretty excited to get playing with that with this, because there could be some fun to be had, I suppose could be said. So before we get into it, please do feel free to subscribe. I am trying to hit that 100K plaque, which we're closer to than to 0, so that is always nice. Additionally to that, this model is available online, and like you can just play with it online as we see right here. But for today's video, because we do love our local AI, we are going to be testing this on both the DGX Spark through Comfy UI, where I do currently have it set up and waiting for us to play with it. Additionally to that, we're also going to be testing it in a cloud GPU. I do have an A100 on standby rented just to see some of the speed on a proper system and not something like the Spark, which is a bit memory constrained. So with that, let's take a peek at this model and some of the interesting architectural considerations, and then we'll jump into some fun and light testing. Now, to begin, I would actually like to start on the GitHub repository for this model, because it shows us a bit more concise the information pertaining to the different sizes and things like that for this model. So we can see right here, of course, as we'll look at a little more in the technical section, they do also talk about the core architecture of it, which is this Neo Unify thing, which is just a blog on Hugging Face, which has some pertinent information about that. However, we can see if we scroll down here that there are a bunch of different variations of this model. So we have this LoRa adapter, which speeds things up massively and produces relatively decent generations for 8 steps, which is pretty low in the scheme of like image generation and things like that. However, this is an interesting architecture because, as we'll find right here in this parameter breakdown, this is not just an 8 billion parameter model. It is actually 8 billion parameters per like half. So as we see right here, it makes a little more sense if we say it contains roughly 8 billion understanding parameters and 8 billion generation parameters. So basically what that means is the VRAM utilization that we are going to be seeing for this model, as shown right here in bfloat 16, is around 35 gigs. So the total parameter size, as we see right here, is like 17.5 billion parameters. So it's just interesting architecturally and definitely something that I want to bring up. We will also hopefully soon have the 3B variation, which I would imagine will be kind of a 6B model in the same way the 8B is 8 in and then 8 out, or non-scientifically, but because that will open up a lot of ability to run this on more resource constrained devices, as opposed to needing that 35 gigs or around that sort of size. So in terms of the unique architecture for this model, I'm not normally one who just wants to like regurgitate the page back to the person who's watching the video. I try to not do that, but in this case, I do believe that may be one of the more ideal ways to talk about this architecture. But one of the things to note immediately right here is they say, rather than relying on adapters to translate between modalities, SenseNova U1 models think and act across vision and language natively. So that would be kind of the native unified multimodal architecture that they talk about here. Additionally to that, there is also a specifically linked blog post for more architectural information about this model, just here on Hugging Face. However, for the purpose of this video and to keep things kind of concise and more focused on actually testing the model and having some fun, we can see right here the key pillars as they have chosen to outline these with a crane emoji. So that's, you know, that I suppose that works. At the core of U1 is Neo Unify, a novel architecture designed from the first principles for multimodal AI. It eliminates both visual encoder and variational autoencoder, where pixel world information are inherently and deeply correlated. Several important features are as follows: model language and visual information end-to-end as a unified compound. So basically that's just talking about the unique architecture of this, where it's different and unified so that it does not kind of translate between modalities like from text to image and things like that. It tries to, as they say up here, translate instead of translating between modalities, it thinks and acts across language and vision natively. So finally, before we just get into testing it, at the bottom of this GitHub repository, we can see there's a bunch of specific ways that we can use this. So there's visual understanding, which is actually kind of interesting because the example prompt right here is essentially sending it a menu and asking it what specifically it would recommend. So it can see the image and then understand it and then respond, which is neat. Also, we have our normal text to image where we can just describe an image and then it will create it. The default resolution is 2048 by 2048, which is fairly large, so it'll be interesting to see how the speed for something that size is, especially on the Spark. Image editing, now this will be interesting. I don't really know what to expect here, but it's interesting to have nonetheless. And then finally, this interleaved generation, which is probably where my interest lies the most, because this is where we can essentially start to have fun with infographics and things like that. So it'll be interesting to play with that. And really our next step now, at least for the beginning of this, we are going to, of course, play with this on the DGX Spark as well as an A100 that I do have running. However, for now, I do just want to run a few things through the Studio app right here, where we have U1 Fast, and as it says right here, this is an accelerated version dedicated to infographic generation. So I think there's probably some like crossover here between speed and then quality. I do want to try some infographs, and now I have to think of some prompts, which shouldn't be too difficult. This is just going to be an initial test. Keep in mind that there is like the thing garbage in, garbage out. So this would be probably considered a fairly lackluster prompt, but I think it might be kind of funny because I've basically told it to generate an infographic that would show us having a computer that is powered by somebody doing bicep curls, which is, who knows, with, you know, ridiculous for now, but maybe in like 5-10 years, there may be such a contraption as to do this. Okay. All right, let's take a peek at this. So, and again, this is, I mean, this does also have the capability to just do general image generation and things like that, which they do have some examples of right here. But I find, and my personal interest in this is definitely more in the infographics because they can be funny and it's probably better suited to this. So, okay, we have mechanical to electrical conversion. I will say the bicep here does look quite nice. 74% energy capture efficiency. Interesting. It almost went ahead and actually like tried to design the device as well beyond just like showcasing the like concept. So what I see right here, there's there's like a little electric motor, okay, or the sustainable energy matrix as it says. I would imagine like if you curl that and then you would spin like the middle handle and then it would power the GPU. Sustainable desktop power. That is a laptop, so I will knock it there in terms of its like attention to detail. Future integration, wearable microgrids, advanced personal energy harvesting. That is a terrifying sentence. But environmental impact, reduced e-waste, autonomous computing, projected energy contribution for 2025 to 2030, renewable kinetic source. And that's our environmental impact. Overall, I do have to say this. Oh, okay, so I was looking, and right as I was about to say, I don't see any spelling weirdness or anything like that. We unfortunately did lose with sustained cron emission. Oh, yeah. Okay, but everything else there aside from that was actually not bad. And I like how it actually went ahead and designed the device as well, beyond just doing like a funny infograph. I have to balance, like, can I post this on YouTube? And this is funny. Let me try something like serious. All right, so I've gone into the sample image gallery because I want to see how long the prompts were that were being used to generate these, which were significantly longer than our bicep power device. But I've now gone and just translated one of those and used it like in the same format, but of course into English, and it is still going to be the comic book style. Now, this specific one is for two people arguing over whether they should use a unified memory Mac for AI or a beefy NVIDIA dedicated GPU. So we'll see how this goes. And the whole prompt is quite lengthy here, so I was actually surprised to see it did all right with the like one sentence prompt that we previously saw, especially when I noticed in the gallery there were all like multiple paragraphs like this. Oh, all right. Desktop war. Okay, comic guide to choosing AI hardware. The countdown to local AI begins with the clatter of keys. Okay, this is our Mac Mini fan. Unified memory is clean, quiet, and efficient. No way. A dedicated GPU is the real compute beast. Feud. Okay, very good. Boom. And we do have like the Dodd comic book style there. Unified memory, flexibility, and dedicated GPU collide on the same desktop. And then this one's more eco-conscious just throughout like the progression of this specific side of the pane. And then we also have this individual CUDA, NVIDIA. okay, I do like seeing these specific graphics coming out of the desktop there. Then we have unified memory and dedicated GPU. I want quiet efficiency for large local models. I want full CUDA power until the VRAM glows. Inside, there is no single winner, only the right battlefield for your AI dreams. Okay, so next up, we're going to be testing this locally on the NVIDIA DGX Spark. I do have this all set up right here through Comfy UI. There was recently, like a couple of days ago, I think the Comfy UI workflow was released officially for this, which will make it simpler for a lot of folks to be able to play with and test, given that this is a pretty well-known software. So with that, we're at least going to just begin with the text to image with the 8-step LoRa, as this will run pretty quickly on the DGX Spark, being that it is a little memory constrained in terms of bandwidth, and I do just have a really simple sample image prompt right here, nothing really funny, at least yet. And we're going to run this right now. Now, I do believe this may take a little bit longer because, okay, no, I didn't know if the model was still loaded in memory right now or not. It seems to have already been loaded in memory, as it would not be going this quickly if it still needed to load the model. So we're going to see this, and keep in mind, this won't be like a full measure of maximum potential quality right here. This will just be kind of showcasing that even on the DGX Spark, it can make a little infograph, or not an infograph, but kind of like a visual much quicker. So, okay, so we have the DGX Spark U1 lock Spark. Okay, so we're going to notice that like some of the text and stuff is not necessarily like words that one would commonly come across. However, something I will note that I am actually quite pleased with is the actual drawing of the separate letters is quite clean. So although this is like not a word that I've normally come across ever, it is like actually the individual letters are drawn nicely, and we do have some interesting like 1, 2, 3, and then 2 is going to 2, 3 is going to 4, and then we have 5, and then 8 is up there. So again, this was more just a measure of speed on the DGX Spark right here, and we can see this is a pretty big resolution for this photo right here. I mean, if we were to really like zoom into this, you can see this is actually like to generate an image at this resolution on this system at a reasonable speed like that is always nice to see, and that is kind of what the 8-step LoRa really kind of creates. But now with that, I think we can perhaps have a little fun with this. All right, so I'm just going to change the subject here, and we'll see what it does with this. And keep in mind, it should run pretty quickly here, but I am somewhat interested to see how it goes about actually coming up with the graphical depiction of this idea, which I would imagine would be like an angry human with like rage lines emanating out of their head as they look at a phone, and maybe a face like, and then perhaps a graphics card being powered. So, yep. Okay, so that was actually, I mean, okay, so we're going to notice the text is not necessarily speed ditch. So we have the word down here, but if we focus more on the actual visuals right here, this is very good adherence to the specific thing that I had outlined. Kind of, this was aside from perhaps that, this was more or less what I had envisioned in my head, where it's an angry person. Although they do, to be honest with you, this looks like the skin you could get on a graphics card like in like 2007, 2008. I feel like a lot of cards had like these sorts of graphics just overlaid on them. As a fact, I even have some that like look like this. But okay, well, now this I'm actually going to save, because something I will want to do is run this in a stronger one. So, okay, so right here, we can see that this is not running on the local Spark. This is using an A180 gig, thanks to the homies at Thunder Compute, who have allowed me to have a large allotment of free compute. So thank you to Thunder Compute for allowing me to do things like this on your A100s, H100s, etc. But now what we're going to do is, this is the 50 step one running on the A100 right here. Now this is likely going to take a little longer, at least to begin, because this will need to load the model in fresh, but it will produce hypothetically a much higher quality generated result, being that as opposed to 8 steps, this will do 50. All right, the model has been loaded in now, so it is just going through the 50 steps. As we can see, the progress bar here is moving significantly slower, because this is doing, if my calculations are correct, around 6 point something times as many steps as it did with the 8-step one that we ran on the Spark. But I will be very interested to see how it differs from this. All right. And this is, again, just the text to image. So we're not doing any specific infographic things right now, or the interleaved one, which is actually really quite neat. And we'll focus specifically on that at least a little later, because that's a rather unique thing to actually witness. And again, this is on an A100 from Thunder Compute. Oh, wow. Okay, so it's interesting. I will say it is possible that more steps didn't really help. And I think this actually speaks to more of the impressiveness, at least of seeing how this runs on 8 steps, as opposed to running on 50, where we don't necessarily see anything that's significantly better here. There may be some more like visual fidelity to the actual graphics here. Yeah, okay, I could see that. But in terms of the actual text, it changed nothing really at all. And this is the text to image path, so this is not the specific like infographic one or things like that, which we will test additionally probably right now. And I will at least start out the 8-step ones from the Spark, because it is always fun to run things locally if we can. So next up, I'm going to be using the infographic 8-step workflow. Okay, okay, maybe I'll just keep that one open for now. And we see I have like a sample one in here just from when I was setting this up, where it basically just talks about like some things pertaining to the model. I guess I'll run this just to see what it looks like in terms of the ideal generation that we should be seeing right here. And we can see this is going pretty quickly because it can use the same model that's loaded in right now, so it didn't need to like dump it and then reload it. Okay, and then we have an infographic here. Just on first glance, everything here actually looks quite good. I don't see anything here that is actually off. I will look at it more fine-grained, but in terms, that was a 2720 by 1536, 16 by 9 photo. So again, the resolution here is fairly high. SenseNova U1 Neo Unify, one native model for understanding and gen, traditional multimodal stack. Okay, yes, yes. Yeah, all the text here was spot on, so this perhaps would have been better for the Rage-powered GPU. All right, so I've modified this to basically create the same concept that we had before, where it's creating the VC pitch titled Rage Compute Human Emotion Powered GPU. So I'll be interested to see the text as well as the actual graphics that it chooses to use here. I would imagine this will be more kind of like PowerPoint-ish and less perhaps visual. Very good. Rage to flops conversion engine. Genius. Raw human rage input, unstructured emotion. Angry Reddit threads, comments, sentiment, extractor, wasted outrage, caps lock intensity meter, downvote volatility, toxicity heat capture, wasted outrage, seed round ready, synthetic benchmarks 10 times matter, angry Reddit comments for the pilot dataset, and then we have our rage to flops conversion. Okay, some oddities here, but there is a lot of text that was denoted with this prompt, and then it kind of gets a little oddity over here. Meme-derived boost clock. Okay, that is understandable. Now, next up, I want to showcase something that is quite unique to this model, where this is the Interleaved storyboard demonstration, and essentially what we're going to be seeing right here is this is going to almost reason through the actual process of generating these images, and we're going to see in this specific pane here, when we do actually get the output, let me just close the workflow tab, we're actually going to see text generated as well as images as well as additional text. So we're almost going to see the model natively produce text and images kind of interleaved, I guess could be said. And it's interesting to see this process because it's using both modalities to actually come up with the final answer. Now, inevitably, of course, the specific prompt right here, at least for the first time, is just a simple technical demonstration of what this is actually doing here. So this is just saying local DGX Spark. This is running on the Thunder Compute A100 right now, but I do want to just showcase it at least with something a little serious first. And we're going to notice this will take a bit longer because it still needs to actually like load in the model, and then it will take a bit of time additionally to that because it also has to generate the text and the images, as we'll see right here in this specific pane. So we can see right there that yes, we got our output there, but that's not necessarily what I'm focused on right here. What I find interesting, and we're going to notice it also did produce 2 images as was denoted in this prompt, but it's actually generating this text here as well, and we can see that it's actually thinking through this, so it's able to basically reason about what the image is going to contain, and it's simultaneously generating the images and this text. So it's almost generating the text kind of how you would just see like an autoregressive LLM or something like that do this, but it's just, I find this architecturally to be very interesting because this is vastly different than like our normal text-to-image stuff that we may see. Okay, this layout emphasizes the technical workflow and local deployment capabilities, and it's just building that based off of the specific prompt right here. So this text is actually coming generated from this model and how it's interpreting and understanding this prompt right here. Then we get one image result right here. Now, I see the verdict is perhaps a bit difficult for one to parse, but everything else prior to that is actually cool. But the whole point of this is not necessarily even to see this. It's unique architecturally, and I find that really at least kind of interesting. I suppose if you're still watching the video at this point, you probably will as well. And this is definitely cool to see. So we can see more text right here, and then we have our second image produced down there, and then finally we have some text there. An interesting conclusion: fail, fixes needed. So look at this. It actually was able to assess the image right here, successfully captures the layout and the tech review aesthetic. However, there are several visual redundancies and alignment issues that need correction. Specifically, the bridge sentence optimized for local hardware and iterative generation is repeated twice, creating unnecessary clutter. In the comparison panel, these are duplicated with their respective boxes, so it's noticing this as well, which looks like a rendering error. Additionally, the main title is missing the model or locally DGX Spark suffix mentioned in the content requirements. The vertical spacing is also slightly cramped due to the redundant text. Conclusion: fail, fixes needed. So now if we go and we'll take a peek at what we see right here, it didn't go ahead and fix it following that because we told it only to generate 2 images here, which it did. However, it's really interesting to see that it's actually able to assess its own output here and then reason off of that, which I just find like it's architecturally kind of cool. All right, next up, I want to try this, but with something that we're all likely familiar with. Well, I would assume most people would be. It is relating to Doc Brown's time machine from the movie Back to the Future. So it has things specific to the film like 1955, the DeLorean, the 88 mile per hour threshold, the flux capacitor, and things like that. So we should get some form of infographic as well as some interleaved text generation here as well, with a couple images pertaining to the time machine and the movie BTTF. All right, we should be about to get our results. Very cool. So we see that this has generated a large amount of text. Okay, I do see almost like an inverted DeLorean there. The design plan aims to transform the iconic DeLorean time machine into a high-end tech. Now, I'm not going to read this through verbosely. I just find it cool that it's generating these like interleaved or whatever you'd like to call it. All right, let me just take a look at some of these. So obviously the first thing right here is a bit unique, one could say. We have our normal mall parking lot, and then of course we have our 1955 Hill Valley arrival. It reads, and it's good at actually reading the specific text right here. Verdict: a 10 to 10 for temporal reliability and 88 miles per hour performance. Okay, and then we have the Del Cran's time machine tech review. So the text here is a bit not 100% proper, but it does all it also does understand that. So it's good at actually assessing these and then saying like, oh, okay, this needs some additional fixes and things of the sort here. But the whole cool part of this and why I want to demonstrate this is the architecture is very interesting in the way that it's going about doing this, where it's doing like text and then an image and then text and then an image, and then it's giving us our conclusion there, which is fail, fixes needed. And it's good self-awareness on the part of the model, which I am happy about. And then we can see those are just the same images that we received right here in this pane. Now I want to just do something like odd. So again, this is where usually all the image testing videos at some point kind of descend into chaos. This would very likely be that point in the video, but I will say I think I kept it together longer than normal, so that's good. This is that's just not right. Okay, what other fruits do we have? Oh no, let's do maybe not a human turning into a helicopter. And again, I don't know, like, you know, do you think the helicopter will have banana-like aesthetics to it? I think it will. I think it'll be yellow. Oh, nope, it's not. That is... So the skulls are pretty consistent across generations here. This is quite something. And again, this is a fairly large resolution right here. Let's try something that's perhaps not as disturbing. A beautiful... And it was interesting the way that that's almost like transparent to the actual background. Not as entertaining though. Let's try Steve the PC Repairman. Steve the PC Repairman. Very good. Okay, he's using a heat gun on some form of flat motherboard. I like the apron. All right. Steve. Okay. I mean, it was cartoon style. I wasn't necessarily... I didn't really know if it would... I kind of assumed it would be. You try some of these old school tags that used to help image generations, like back in the days of early image models that could run locally. Interesting. That was almost like an identical, like, juxtaposition. It just changed it from cartoon to non-cartoon. Very interesting. And that is inevitably a Mac. So for those of you that are familiar with the lore of Steve's PC Repair, this is actually quite a fitting image. Very interesting, and overall that is probably going to wrap this video up. I don't have a traditional, so to speak, results overview because we've just been generating these through Comfy UI as we go. Obviously, this model is just interesting from an architectural perspective with specific emphasis on this interleaved generation capability, where it's generating the text and images in parity almost, and then it gives us the end result here as well. But seeing the ability of it to actually judge the end generated photo right here is very interesting, and its focus also on the ability to do like infographics and things as we had seen in some of the other nodes that we tested on the DGX Spark is pretty cool, and it's just architecturally unique as well as Apache 2.0. So I figured I'd take a peek at this because I'd seen some other coverage on it and it was kind of interesting, so I wanted to also throw my head into the ring, so to speak. So that is going to conclude our first look and test of SenseNova U1. I am going to be interested to see if the 3Bs come out at some point because those will definitely lower the barrier to entry to run this in a local system. Additionally to that, I noticed the 8-step, like the quality difference between the 50-step and the 8-step was not like insanely large, which was very interesting to see, and it did run very quickly even on the DGX Spark as we saw right here with that 8-step result, so that was also nice to see. So that is overall going to conclude our first look and test of SenseNova U1. If you have any questions, please feel free to leave them in the comments, and thanks for watching.